Besides monitoring MOC, we conduct many other activities to monitor ocean transport. The main objective is to understand the impact of ocean transport on climate anomalies and weather events. Ocean transport is much more complex than the simplified two-dimensional overturning structure. It involves mixing eddies, gyre circulation, in particular, the narrow strong boundary currents, which are the main carrier of ocean heat and other properties around the globe, which is why, in addition to monitor large-scale global ocean circulation through Argo and Drifter programs, we lead NOAA efforts in monitoring boundary currents in the Atlantic Ocean using various observing platforms. In collaboration with more than 30 countries using 12 observing platforms, we're monitoring about 20K ocean currents in the Atlantic. I'll briefly give you a couple examples. What do we monitor and how, and what we have learned. First, the western boundary current in the North Atlantic, the Gulf Stream, which is one of the most studied ocean currents due to its broad range of impact on climate and weather. In addition to the extensive observing activity at the Florida Straits, we also monitor the Gulf Stream farther downstream from 3 SBT transect. In this region, studies have found that the coastal sea level rise has accelerated and attributed this acceleration to a slowdown in the Gulf Stream. When the Gulf Stream slows down as a dynamic response, sea level decreases on the offshore side of the Gulf Stream, but increases on the inshore side, which explains the acceleration. However, our data tell a different story. The coastal sea level in this region indeed increases at a higher rate than global average. However, we do not see a slowdown in the Gulf Stream. On the contrary, our data shows a slight increase in Gulf Stream transport. Further analysis shows that the sea level on both sides of the Gulf Stream has increased due to warming and increasing water mass. This is different from what is happening upstream at Florida Straits, which you will hear from Ricardo. The western boundary current in the South Atlantic, the Brazil current, although it's much weaker and shallower compared to the Gulf Stream, it is the main carrier of ocean heat from tropics into subtropical region. Ocean heat content changes in the subtropical South Atlantic can impact global precipitation through monsoon system. It also impacts regional weather pattern. We have been monitoring the Brazil current from SBTs, Argo, and altimeter. Our ongoing study suggested that the warm condition associated with the stronger Brazil current increases convective evaporation, which leads to strong precipitation in southeast Brazil. We also monitor the deep western boundary current in both North and South Atlantic from moorings. DWBC is the main carrier of southward flowing cold water in the lower limb of MOC. Our measurement shows large variability in the transport on short time scale. Our goal is to understand the attribution of those variability. As you can see, the water column consists of various water masses, each with distinct characteristics and has different impact on global ocean circulation. Our understanding of climate system to a large degree rely on climate model. Therefore, it is important to evaluate how the model reproduces the observed process. Here is an example of model data comparison of temperature at 1,000-meter depths, which shows that the semi-fine models were unable to reproduce the flow pathway of warm salty water from Indian Ocean into the Atlantic, which has been suggested as a forcing for MOC variability. Our data has also been used to evaluate ocean forecast model. The example here shows that the record low Florida current transport during Hurricane Dorian is well captured by 24-hour ocean forecast. However, as expected, the forecast model performance decrease as the forecast hour increases. Our plan is to work with modelers to further evaluate and improve model. So this is what I have to demonstrate the value of long-term climate record. Thank you. My pleasure to introduce my colleague, Dr. Hazmi Lopez.